Okay, now we want to review some of your things that you should know in terms of simplifying square roots or radicals, as they're sometimes referred. First off, okay, you should know all these perfect squares. Of course, you should know all the perfect squares from 1 to 20. Okay, so that in other words, I'm presuming we say 8 squared, we know it's 64, right? And I'm also presuming we know something like 9 squared is 81. But then, okay, you need to know that 13 squared is 169. 14 squared is 196. So therefore, you could answer like the square root of 225 is 15, because you know 15 squared. You got to know these things, okay? You're going to have problems if you don't know these by heart. So you need to know the first 20 numbers and their perfect squares. So 16 squared, 256, 17 squared, 289, 18 squared, 324, 19 squared, 381, 20 squared, 400. Okay, you need to know them inside and out, backwards and forwards. So backwards would be saying, oh, well, what's the square root of 289? Well, I know it's 17. You need to know that from the top of your head because you know these numbers up here. Square root of 324, well, that's 18. 256, the square root of 256, 16. Square root of 196 is 14. Okay, so you need to know all those. All right. Now, most of the time, the numbers that you're going to see are not going to be perfect square numbers like these. They're going to be something times a perfect square, like you see here in the next grouping. Okay, so in other words, 200. No, that's not a perfect square, but it is. Okay, 200 is 2 times 100. And there's rules for radicals which allow us to say that if I'm taking the square root of 2 times 100, it's the same thing as taking the square root of 2 times the square root of 100. Now, of course, I recognize that, okay, the square root of 100 is 10, so that this can then, the 10 can come out of the square root or out of the house, as they sometimes say, and that's simply 10 the square root of 2. Now, likewise, 50, you should recognize, well, yeah, it's 5 times 10, but it's a perfect square. It's 25 times 2. So I could immediately say it's the square root of 25 times the square root of 2, or 5 the root of 2. Likewise, 18, okay, could be written as the square root of 9 times the square root of 2, which is 3 the square root of 2. These are left this way. We don't need a calculator to evaluate these. In fact, coming in the upcoming test, you won't have a calculator. I will expect you to simplify these expressions the way I'm showing you here. 72, well, again, most of the numbers we're going to give you are twice or 3 times a perfect square. So, yeah, if you can't find the perfect square going in, think about dividing by 2 or 3 and seeing if a perfect square comes out. And sure enough, 36 and 2 is what this breaks down to, so it's 6 to the root of 2, or 6 radical 2, as we sometimes say. Okay? Now, just as those numbers were twice perfect squares, these are going to be 3 times a perfect square. 27 is 9 times 3, so square root of 9 times the square root of 3, which is 3 the root of 3. Okay? 48, okay? Now, if you didn't recognize it as 3 times 16, somebody might say, well, I know it's 8 and 6, okay? Well, or I know it's 4 and 12. Say we went 4 and 12. It's the square root of 4 times the square root of 12, so that's 2 the root of 12. Now the root of 12 has to be broken down as 4 and 3. So then that's 2 times 2, 2 times 2 times the square root of 3, which is 4 the root of 3. But if we had saw right away that this broke down into 16 and 3, we would have gotten there a little quicker. So there again, we're saying, oh, I don't know 147. Well, divide it by 3. Divide it by 2? No, it doesn't divide by 2. So let's say divide by 3. Sure enough, when we divide by 3, we get 49, and we get 3. So that's 7 the square root of 3, sometimes referred to as 7 radical 3. You say 75. Oh, well, that's 25 times 3. Yes, that's 25 times 3. So the root of 75 is the root of 25 times the root of 3, which becomes 5 the root of 3. Okay? All right. Now, okay, the rule here, or the next set of problems, is that which says, okay, that the square root of 9 over 25 is the square root of 9 over the square root of 25, which makes that 3 over 5, or 3/5. And so you have recognized, hopefully, that these are perfect squares. That's 196 square root over square root of 225. So that should become 14 over 15, okay? 36 over 49. You might say, well, can't I simplify that? Well, you might, but I don't think so. And it's easier just to rewrite as 36 radical over radical 49, which becomes 6/7, okay? Square root of 64 81st, so the square root of 64 over the square root of 81, which becomes 8/9, all right? And we move along, okay? Down here, decimals. Well, decimals are fractions, okay? All right? 1.21 is, okay, 1 and 21 100ths, all right? Which becomes an improper fraction as 121 over 100, which now, okay, by rules of our radicals becomes the square root of 121 over the square root of 100. So that becomes 11/10, or if you prefer, 1.1. 0.0324. Remember your decimal places. Tens, tenths, hundredths, thousandths, 10,000ths. So as a fraction, this becomes 324 over 10,000, okay, which is the square root of 324 over the square root of 10,000, okay, which is, you recognize that that's 18, okay, and 10,000 is 100 squared, so the square root of 10,000 is 100, so it's 18 100ths, or 0.18. 0.36. Maybe at this point you can recognize it as 0.06. If you can't, you turn it into a fraction. It becomes 36 over 100, which becomes the root of 36 over the root of 100, which becomes 6/10, right? Or 0.6, okay? 16.9, that is 16 9/10. Turn it into an improper fraction. It becomes 10 times 16, 160 plus 9, 169 over, okay, over the square root of 10. So that becomes 13 over the square root of 10, but there's issues with leaving a radical in the denominator. I'm not going to be terribly upset by it. I'm just going to leave it at that for now. Okay? All right. Let's look down here. Now we're combining things. All right? So the square root of 98 should be recognized as 49 and 2. Okay? So then 49, its square root is 7. But I have a -5 to multiply that, and then I have the square root of 2 that comes down 6. My final answer is 35, the square root of 2. This should be recognized as 4 times the square root of 49, which is 7, which becomes 28, right? This is 8/10, the square root of 400. Well, square root of 400 should be recognized as a perfect square. The square root is 20. Okay, we got a nice cancellation here. 10 going into 26, so that's 16. 10 going into 22 times 8, 16. 7/8 the square root of 48. Well, I think we did the square root of 48 before. We've recognized that 48 was 16 times 3. So just the radical part becomes what? Okay, it becomes 4 the root of 3 times 7/8. So now we'll simplify it, okay? The 4 goes into the 8 twice, so I can have 7/2 the root of 3, and that would be the final answer. I'd leave it at that, okay? Here, the square root of 5 times the square root of 6. The rule says the product of the roots is the root of the product, so that becomes the square root of 5 times 6, which is the square root of 30, which I have to leave at that. Here, what's outside, I'm going to multiply, keep it outside. What's inside, I'm going to multiply, keep it inside. There it is. 2 root 5, okay, is the quantity squared is 2 root 5 times 2 root 5, which, again, like this problem over here, okay, would be 2 times 2, keeping it outside, so that's 4. And 5 times 5 is 25, keeping it inside, but that, of course, square root of 25 is 5, so that's 4 times 5, 4 times 5, 4 times 5, 4 times 5, not 4 times, which is, of course, 20. All right, and this problem, I don't know what I wanted to scratch that one. Don't worry about that one, okay? So there you have it. There's a summary of your rules of radicals, okay? So review all those, okay? What I've done is I provided an upload where you can get this worksheet without the answers, and then you can fill them out for yourself and check it against what I've just shown you here in this video, okay? So there's a summary of rules of radicals, and we will have practice with that more tomorrow, okay?